All right, today we're going to cover building models in Cogulator. In order to build a model in Cogulator, we use a syntax called GOMS, goals, operators, methods, and selection rules. If you're familiar with GOMS, fantastic. If not, no worries. By the time we get done with this video, you'll know everything you need to know about GOMS in order to build basic human performance models in Cogulator. Now, instead of going through each of those terms and defining them, I think what I'd like to do is just jump right into building a model, and each of these things will start to make sense as you see in an applied example. The applied example we're going to use today is entering a phone number into the context of an iPhone. So in order to do that, we press the iPhone icon on the home screen. Then we jump into plus in the top right. Then we'll enter the first name. Let's say it's Alan. We'll select the last name field and enter Newell. Then we'll select the phone number field and enter 912-897-4987. All right, we'll start simple with just basic model building. We'll add some complexity by adding structure with goals and methods. Then we'll get into multitasking. So how can we do two things at the same time in our models? And we'll end up with chunk naming, which allows us to look at working memory load and subjective workload. All right, so with all that in mind, let's jump right into some model building and see what this is all about.
All right, let's start building this model. We're going to start by creating a new model. Let's call it add contact to phone. Hit create. We've got a blank page. So let's think about how we build models in Cogulator. Basically, for each action that we need to take, and let's think about the first action, which is opening up the phone app so that we can put the contact in it. For each action that we're going to take, let's think about the perceptual, the cognitive, and the motor actions that are necessary to make that step happen. So in order to open the phone app, what motor actions do I need to take? And that means doing things with my hands or saying something. What cognitive actions do I need to take? And what perceptual actions do I need to take? That is, what do I need to look at? What do I need to hear in order to accomplish this step? We're not going to do cognitive right now. We'll come back to that later. So let's really concentrate on motor and perceptual. And really, the best place to start is usually with the motor action. And the motor action in this case, right, is touching that icon on the screen. So the question is, how do we represent touching an icon on the screen in Cogulator? Well, one easy place to start is with this insertion shy. We'll click operators. We see a whole bunch of list of actions we can take. Right now we're going to concentrate on the hands row. All right, in Cogulator and GOMS more generally, operators are the actions you can take, and we expect an operator in every line. That'll make more sense here in a minute. So let's look through the hands row. We know that we're going to touch something on the phone, and let's get a sense for what our options are. Okay, so I've got click right here, and there's a green info button beside it. I'll hit it. It says time 320 milliseconds. Okay, fine. Description, press of a mouse button. Well, no, we're not trying to press a mouse button. This is a touchscreen interface. So let's keep looking. Go down, hands, keystroke, no, point, maybe that's it. 950 milliseconds, move a cursor via the mouse. Nope, not trying to move a cursor via the mouse. Tap, it could be tap. Touch a series of virtual buttons. No, we're not trying to touch a series of them, we're just trying to touch one. Touch. Press a virtual button associated with the touchscreen device. This is it. Okay, so this is the operator we want to use. Now, I'll mention, sometimes you'll come up with an action there is not a pre-existing operator for, and you have a couple options. You can create new operators in GOMS, and if you want to know how to do that, you can go to cogulator.io and look in the primer section, or you can, hopefully you've already reviewed the interface video and you'll get some information on how to do that there. But right now we found the operator we want, the action we want to take. I'm just going to click it, and that adds it to our model. Notice we now have a task time. It's 0.5 seconds, so about half a second to touch something on the screen. So again, we want to think about the motor, perceptual, and cognitive actions we need to take. We're ignoring cognitive for now. So what perceptual action might we need to take in order to touch something on the screen? Well, in order to touch something, we need to look at it first, especially on a touchscreen device. And as it happens, Cogulator has made a little suggestion. It says typically a look precedes this operator. There's no error here. It's just making a suggestion. And if I want to take that suggestion, I can hit fix. And it puts the right operator for me right there before touch. And now I have a complete model for opening the phone app in Cogulator on your iPhone. Now, we've got the look. Let's take a second to look at the look operator, so to speak. And then we'll look at what this label is all about. So let me go back in here. And the action we took was look. So our operator is look. We'll hit info. Says 550 milliseconds. Look at an item in a known position. So that makes sense. Typically, you're going to know where your phone icon is for your phone app. Great. Now we could look at some of these other ones like search. Search for an item in an unknown position. And then there's Saccade. You probably won't use that a lot. It's a lower level operator. Read and proofread. You may use those some. Probably won't use perceptual processor a lot. Look and search are really going to be the prime perceptual operators, perceptual actions that you take a lot. All right, great. So what about this label here? Well, every line I said requires an operator. So if I do this and make it something that's not an operator, it says I couldn't find that operator at the start of this line. So it wants me to have a valid operator spelled correctly. Cool. And it's got at target. So what happens if I type gibberish here? Nothing. Task time still a second. Model still valid. Again, if I X this out, you'll see the model's not valid. We get these X's at the top. So let me go back and turn that to look. What these labels do is they allow us to provide some contextual information so that when I go back and look at this model later, I have a clue as to what it's talking about. So I'm just going to put look at phone app icon, touch phone app icon. And we now have a completely valid Cogulator model. That's just for that one step, but that's all there is to it. I could have just done look and touch. Again, perfectly valid. I don't have to have the label and all that, but it's nice to have when you go back to it later. Cool. Okay, so look, touch, perfectly valid. Let's move on to the next step, and we're going to build the entire model using the Magic Models tool just to speed things along, and then we'll talk about goals and methods. All right, so let's build the rest of this model using the Magic Models tool. Now, before we do that, I think it's probably a good idea. I'm just going to paste a goal outline I typed up here at the top. Now, notice this is all grayed out. These are comments. If you put an asterisk before a line, it's considered a comment, and what that means is that Cogulator will just ignore it entirely. So the nice thing is you can put notes or references up here, and Cogulator ignores it. Notice the task time is still 1 second. So I just put this up here as a breakdown of what the model is going to look like as we build it. So let's go down here and then open Magic Models. We've already got the iPhone selected. And if you haven't seen the interface video, basically what Magic Models does is it lets us mimic what we do with the phone in this area here, and it'll automatically build the GOMS for us. So let's try it out. We've already clicked the phone app icon, which would have been down there, so we can skip that. And let's go straight to pressing the plus button, which was in the top right. I don't have to be precise. I'm just guessing it's roughly over here. Fine. Okay, then the next thing we did was enter our name, and I'm just going to type A-L-L-E-N. Notice it automatically added tap before that and then put Allen. That's because I've got Magic Models open. If I had this closed, obviously that wouldn't have happened. Next thing we had to do was select the last name field. So imagine it was roughly right there. I'm going to type Newell. Same kind of thing just happened. The phone field, I'm just guessing right there roughly. We'll type in the phone number, 912-897-4987. Fantastic. And then everything looks good. We'll hit done, which I believe was right up here. Okay, so we've just built the rest of our model using Magic Models. Let's take a look at what we got. So I'm going to put these together, actually this one and this one and this one and this one, because these are related. This was touching the last name field and then tapping the name in. Okay. And this was touching the phone field and then typing the name in. Now we've got these bracketed right angle brackets around the numbers. These are working memory chunks, what we call chunk naming in Cogulator. We're going to talk more about that here in a minute. But what they do is they add working memory information into Cogulator, and we use that for working memory load analysis and workload. And again, we'll touch more on that in a minute. Right now, let's just focus on making this more readable so that, again, if we come back to this later, we have some idea of what's going on here. So I would do the same sort of thing we did up here. We did look at phone app icon, touch phone app icon. Okay, cool. I'm going to do the same thing here. I'm going to do look at plus button, touch the plus button, and then ignore the plus button. Ignore is a working memory operator, a working memory action, and it means we don't need to worry about this in working memory anymore. We can ignore it. We'll talk more about that later. Okay, great. And I'm just going to fast forward through the rest, put the kind of context information in, and then we'll go from there. Okay, so I've got everything entered in. I went ahead just for grins and put the working memory chunk names up here too. Again, we'll come back to that, so don't worry too much about what that means just yet. And we've got our model. It's complete. It says 14.9 seconds to do this basic task of adding a contact to the phone. Now, one thing we'll often want to do is add some structure similar to the labels here so that we can come back here and know what's what when we look back later. If we add some structure, it gives us an even better idea of kind of what the task analysis was, what the series of steps were that were necessary to accomplish this task. Now, as it happens, I'm going to uncomment all this because I formatted it so that we could turn that into the structure really quickly. And all I need to do is add the term goal. Goal is a way of saying this is a label for a series of steps, and that'll make more sense in a second here. So let me just do goal. Now, a couple things. Our main objective is to add a contact to the phone, and there are a bunch of sub-steps. Open the phone app, press the plus button, enter the first name, last name, etc. Notice that the sub-goals are indented one, and in Cogulator, an indentation, it's just a period. Okay, that's all it is. Now you can add a group of a period or indent or dedent as much as you want, as it were, with these buttons here on the right side. So I could add a bunch of additional indents. And it's just to let you know the kind of shortcut for doing this. But that's how you do it. Just a period at the front is how you indent in Cogulator. Now if I go down, I'm going to add some space. What I'm going to do is pull each of these into here. I'm going to add 2 spaces. All right, so I'm going to do this for the rest in a second. Let's talk about what just happened. So we have a goal, add a contact to the phone. The first sub-goal is open the phone app. The method for that goal, so we go back to GOMS, goals, G, operators, the blue part, and methods, which is just a collection of operators. So the method for the goal is look, touch, ignore, 3 steps. And we designate that this method is for this goal by indenting it 1 extra from the goal level. So this lets us know that this method goes with this goal. And I can just copy and paste the rest, and I'll do that real quick. And just for grins, just going to add some spaces just to make it a little bit easier to see everything. Okay. Task time's still the same, 14.9 seconds. The goal structure didn't change anything about the task time, but it had some organization. So now if I look at the Gantt chart, I can see, press the plus button. So that corresponds to right in here. If I click on that, sure enough, look at the plus button. Tap Allen. Okay, great. So now we've got goals, we've got operators, and we've got methods. All right, let's move ahead and start looking at multitasking and working memory. All right, the next thing we want to look at is multitasking. So what's multitasking? It's essentially doing 2 things at the same time. In the literature, sometimes you'll hear this as task interleaving. What we're going to do is demonstrate how you can do this in Cogulator. Now imagine that to get this phone number in, we're going to ask somebody for it and then type it in as they're speaking it. So let me add a goal here where we say to somebody, hey, what's that phone number? And then we hear them saying the number aloud. So I'm just going to copy and paste that in. Great. And I'm just going to change the indents. Okay, great. So we've got that pasted in. So the goal is to get the number. We say to somebody, hey, what's that number? And then we hear 912-897-4987. Notice that there's spaces between each one of these numbers. Why would we do that? Well, let me show you. If our task time is now 20.1 seconds when we've added here, I rather request that number. Let me change it to just 9. Now it goes down to 16.5 seconds. So 912-897. I'm going to hit reload. Now we're up to 18.54987. Now we're up to 20.1 seconds. Okay, so what's that number here? 912-897-4987. So what's happening is that Cogulator uses this label to determine how long it would take to hear this. And now I've added spaces between each of the numbers because we're treating each number as a word. So 912-897-4987 adds, whatever it was, a little less than 6 seconds to the total task time. And so that's the aside on labels. We mentioned earlier you could type whatever you want to in here and you never get an error. And that's absolutely true. But in some cases, particularly here, type, tap, read, and proofread, it'll use what's in the label to determine how long that operator should last. Okay, so just an aside so you know what's going on here and why these are spaced out like they are. All right, back to multitasking. So we say get the number and then we want to enter the phone number. Let's look what's going on in the Gantt chart right now. So we get the phone number, say, and then we hear it, then we start tapping it out. But what we actually want to happen is we start entering the number while we're hearing it. So how do we do that? Well, we're just going to change this goal for entering the phone number to also. Hit reload. Notice our task times change. It's now 19 seconds. So why is that? Looking back at the Gantt chart. Now typing in the number is happening at the same time as we're hearing the number. So that's fantastic, except you notice there's a little error here. We've got touch the field and now tap is happening way out here. Why is that? What's this? This is done. So look what's happening here. We've got look, touch. This is all part of enter the phone number, right? And then we've got press done happening before the end of enter the phone number. Well, that's not right. You can't press done before the numbers are all the way entered. So what's happening is this is multitasked, but this is going back to what we call the main thread. What's a thread? A thread you consider like lanes on a highway. So when Cogulator starts up, it's assuming one lane on your side of the highway, right? When we use also, it says, hey, let's open up a second lane. Okay, so this is on the second lane. This goes back to the first lane, so to speak, and that's why these get all disconnected. So what you usually want to do in a situation like this, and you won't often run into this, but when you do, it's nice to know how you fix this. You're going to want to put enter the phone number and probably everything after it on the same thread. So they'll be in the same lane. So there's two steps to that. First, I'm going to use also. Okay, what this has done is now I've created a third lane represented by the third color. Okay, I want these two to be on the same lane, so I do one more step. I'm going to call this data entry, and I'm going to copy and paste that over here, and look what happens. Now we've got all this on the same thread that's in the same lane. So we're hearing at the same time we're tapping, and we're waiting to press done until we've finished tapping in the phone number. Great. You now have done multitasking in Cogulator. This adds a good deal of complexity and opens up a lot what you can do in Cogulator. You don't often need to use it, but when you do, it's really fantastic that it's there. So now Let's move on to working memory, and we're going to expand a little bit of what's going on in this hearing and typing at the same time. All right, so let's talk about a little bit about working memory. What we're going to do here eventually is model this stuff going into working memory, and then whether or not we can recall all that as we type it into the phone. Before we do that, we'll talk a little bit about working memory chunks and chunk naming though. So I mentioned earlier that anything in the right angle brackets that's color coded, this kind of aquamarine, is a chunk name. And chunk names are things that go into and are read out of working memory. Working memory is super important for understanding workload. It's a major bottleneck in cognition. So let's see what's going on here. We've got look at the phone app. Okay, great. So we see the look, and at the end of the look operator, we now have the phone app icon in working memory. And that's what's going down here in this part of the Gantt chart. All these color-coded blocks are working memory items. When there are multiple items in memory, as we see in a minute, they'll get stacked up and you'll get stacks of color-coded blocks. So we've got the phone app icon in working memory. The important bit for the phone, for most folks is going to be the recall probability. Right now it's 100%. Now let's do something. I'm going to add a wait operator. The wait operator is typically used as you're waiting for, say, a response from a computer. You're not doing any cognitive, perceptual, or motor activity. You're just kind of sitting there waiting on something. So I said wait for 100 seconds. Let's look at the recall probability. I'm going to go over, and you see, it's starting to decline. Now we're down to 99%. I'm going to zoom out some and scroll over. Somewhere in here it disappears. And we count anything below 50% as out of memory for our analysis purposes. So somewhere right in here, it dumps out of working memory. Now, notice what happened now. Phone app icon in this line is highlighted red. Why is that? It says trying to recall phone app icon, but it is not in memory. What's happened? It's decayed out of memory. It's been in memory so long we forgot what it is we wanted to touch. We looked at the phone app icon, that's in memory now. Then we want to touch it, but we can't remember what it was we were going to touch because it's been so long. If I get rid of this wait, everything looks good again. So a couple important points. One, to get things into memory, we use perceptual operators or cognitive operators. And I'll demonstrate the cognitive operators here in a second. So things like look, hear, search will put things into working memory. And then we test whether or not those remain in working memory when we try to act on them with a motor operator like touch. So that's why this went red when this had been in memory so long that it had been forgotten. Because I tried to touch, but I couldn't remember what it was I was going to touch on. So we get stuff in here, and we test whether it's in there. Why would we do that? Well, we're trying to understand two things. One, we want to model forgetting, because that's important in trying to understand how well your app works for somebody. If they're having a big working memory burden, or they're constantly forgetting things, or having to refer to other resources to remember it, that tells you there's a working memory burden being imposed. And that consequently has an impact on perceived workload. So we've got up here working memory chunks. This is saying that on average throughout the model at any given time, there are 0.2 working memory chunks. And our load is low. This is the subjective workload. That is, if we ask somebody on a scale of 1 to 10 what their workload is for doing this task, they'd say, not very high, it's low. So that's somewhere usually between 1 and 3. We just categorize it because it's not a super accurate measure. We just want to give you a general sense of what somebody might say the workload is. Okay, now we looked at perceptual operators to get things into memory with the look icon. Let's look at cognitive operators. So let's do recall Alan. Alan. And then I'm going to add ignore Alan, and we'll talk about what all's going on here. So let's presume you know the person's name. It's Alan Newell, and you just don't know his phone number. In a minute, we'll model him telling you the phone number. So we're going to recall from long-term memory. That's what recall is. It's saying get this out of long-term memory, that his name is Alan. then we're going to type in what we recalled, and then we're going to ignore it. What ignore means is not necessarily that this working memory item just falls right out of memory, but we don't have to pay attention to it anymore. We're not going to attend to it in memory. And that's important because it has an impact on how full our working memory load appears to us. So ignore says, okay, we're done with this piece of information, and it tells Cogulator you don't need to consider this anymore in the model when you're trying to figure out what working memory load is like or what subjective workload might be rated as. The other option would be store, okay? And that would be more typically something going into working memory directly rather than being recalled from long-term memory. So if I said, hey, Alan, what's your name? And he said, Alan, then that gets stored in working memory. Now, I could do that with a store operator, or I could do that with a here operator, because here also stores things in working memory because it's a perceptual operator. So things that store working memory items are perceptual operators and cognitive operators. Things that test whether or not they're still in memory are generally motor operators. Okay, so I'm just going to do recall in this case for grins. I'll call Alan, and for consistency, what the heck, I'll just go ahead and recall Newell. Oops, forgot the L. And then ignore Newell and put this in working memory brackets, chunk names, brackets, so that we can have that all go in. Okay, fantastic. So now we have a general sense of how we get things into working memory, how we pull them out and test working memory for forgetting and workload. Now, let's go in and model the phone number going into working memory, and it's going in because we have this perceptual here operator, and then we'll go down and test how well we remember it as we try and enter it with the motor operator tab. Okay, so I've already put this in chunk names, so let me copy and paste that in, and then we'll talk about what that looks like. All right, we've got here 912897497. Now we need to take another little aside to talk about what's going on here with these weird first, second, third, fourth, and fifth, okay? Let's go to a new line. I'm just going to do store 0, 0. So we've got two chunk names here, but the chunk names are the same. They're both 0. So Cogulator says, well, as far as I'm concerned, this 0 is the exact same thing as this 0. So this is just one working memory chunk to me. Okay? In order to distinguish these, I say first and second. I could do whatever I want. I don't have to use first and second, but I need something. I could do X and Y. Something to tell Cogulator these are two distinct items in working memory. All right, and so that's what's going on here. There are multiple 9s, for example, in this number. There's one here, and one here, and one here. In order for Cogulator to know that these are distinct, I need to distinguish them somehow. So I just did first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. There's 10 numbers in this phone number, obviously. 3-digit area code and then 7 digits. And that's how I distinguish it. So that's why the first, the second, the third, the fourth is in there, just to make it clear to Cogulator that these are individual and different working memory items. Now, so I put all the phone numbers, in individually, and that's great. Now I need to test whether or not those numbers are, in fact, recallable in working memory as I go through and try and type in the number. So once again, I've already written this out. I'm going to just copy and paste in what I tap here. So what is going on here? We've got all sorts of interesting stuff. First, notice I took the number and I divided up, but put it 1 on each line. This is just for clarity's sake. You don't actually need to do this, but I find it helps, particularly when we come to this. So why do I have this in here? Well, normally, remember I said that tap 9, however many items are in this label determines how long the task time is, right? So if I did 9, that's one thing. And if I did 9 first, that'll make the task time even longer, okay? Now, to make for clarity in working memory, I've added some digits here. So in order to tell Cogulator, listen, I know that this label is 9 first, but in actuality, I don't want it to model the task time based on what's the label. I'm going to override that, and that's what's going on here. At the end of any line, you can add a parenthetical and put in a time. So I've done 450 milliseconds, which is the time to tap one thing on the screen. I could do 10 seconds if I wanted, whatever. Doesn't make any difference. I can put whatever I want there and override the task time for an operator on a line-by-line basis. And that's fantastic. You'll find that's really useful in a lot of different cases. So the reason I've done it in this case is because what's in the label doesn't reflect what's actually being typed into the phone, and I want to make sure Cogulator's using the correct task time. So I just forced it to use 450 milliseconds. All right, so that's the first thing. Now the second thing is, as we saw earlier, we've got these red error markers, meaning this stuff is not in memory. So let's see, trying to call the 9/8, so that would be this one, but it's not in memory. So let's go in here and take a look, see. Now, we see a bunch of stuff going on as we've added all these numbers into working memory. That's fantastic. But essentially, we've overloaded working memory. Most folks can't handle a 10-digit number. Now, as an aside and something to think about, a lot of times an area code could be treated as one chunk. So if I hear 912, that's my area code. So I don't remember that as 3 individual digits. I remember that as my area code, which is 912. So it helps to have some insight into how the user is chunking the information. But in general, for something like a phone number, those are going to be 10, in this case, individual digits. If it wasn't with the area code, obviously it'd be 7. So I've divided up into 10 individual digits. So that's just something to think about when you're actually encapsulating these things so that they're working memory chunks. But what do we do here? So we've got our memory coming in, and it's decaying fast, and not all of it made it in because the number was too long. So one of the things that we might want to do here is model the person saying, okay, we've forgotten, so let's go in here and say ask for the number. Now I've got a method. Once again, I'm going to go and copy and paste it in, and we'll see what that looks like. All right, so let's come in here. I'm just going to paste in this method. Also, ask what those numbers were again as multitasking, and I'm going to make this data entry. Again, we want that to be on the same thread. Now, so I did the last 44987. Doesn't matter. We got all the numbers into memory now. So when I asked for them again, fantastic. Now I can finish typing in the model. So we've done a bunch of cool things here. One, we've identified an area where some users may have difficulty because of working memory load. We've identified an area where forgetting is likely, and we've identified an area where we might want to use some error correction methods. In this case, shoot, I forgot what the last 4 digits were. Tell me those again. And we've gotten those again. So that's going to improve our modeling accuracy too, if we can know that there's going to have to be error strategies employed often when doing this particular task. So let's cover just a couple more things. These will be fairly quick, and then we'll sum up, kind of talk about where we are in learning about how to model in Cogulator. In a minute, we're going to talk some more about the mental operator and when we should use it and not use it. But before we do that, let's finish up this model with some goal references. So let me paste something in, and then we'll talk about what a goal reference is. Okay. All right, so I've got goal press phone app icon. Basically, I've now made this a sub-goal of open phone app. Why did I do that? Well, check this out. I'm going to go at goal, press, this time I'm going to do plus. I'm going to delete these 3 lines. Hit reload. All right, so what have we done here? Well, this is a goal reference. We have this goal, press phone app icon. And we've established the goal here. It's got 3 steps: look, touch, ignore. Later in the model, when we use a goal reference by using at goal or at also, we're saying, hey, go find this press goal. It's 3 steps, And what we're going to do is reuse that again, except for this time, instead of using phone app icon for the chunk name, use the plus symbol. So this saves us, a few steps here. Goal press last name field. I could do this a few other places. Do goal press phone number field with one change here. Because I want this to continue on the thread, I'm going to do also, but it doesn't care. It's still going to look for the press and put that in. And I'm going to do the same thing down here. I'll do also press done button and get rid of those. So those are goal references. It's just a way to minimize your amount of typing. For a simple goal like this, maybe it's worth it, maybe it's not. Sometimes you'll have fairly large goals that you want to reuse, or you want to do the same goal several times in a row. And in that case, the goal references are really nice and help cut down on the amount of typing and make it easier to scan through the model because it's not quite as long. So that's goal references, pretty straightforward and easy. As with all this stuff, you can see more information in Cogulator.io and going into the primer section. Let's jump out of this, wind up with talking some about mental operators, and then we'll kind of review where we've been. Before we finish up, let's go and touch on cognitive operators. We mentioned earlier that we kind of breezed through them and we're going to come back to them later. We've actually used a few. We've got ignore, which removes something from working memory. Recall, which retrieves something from long-term memory and puts it in working memory. But the working memory operators, or rather the mental operators that folks tend to have trouble with are these: mental, think, and verify. Let's check these out real quick. Here's mental. I'm going to press info, and we see it's 1250 milliseconds and it's a generic operating for thinking. Okay, cool. Let's go down to think. What does that say? 1250 milliseconds generic operator for thinking. All right. What do you think this one might say? 1250 milliseconds generic operator for thinking, verify. So these are the same thing. They do the exact same thing in Cogulator. They're all cognitive operators. We'll see they're all on the cognitive line. Okay. And they take the exact same amount of time. Why do we have three different ones? Just for syntax is the answer. So I might do think of procedure to accomplish goal, just kind of randomly. And then I might say verify goal accomplished. Okay. From Cogulator's perspective, there's no difference here. From your perspective, it just may be more readable to use verify rather than think. And that's fair enough. But the real question is, when do I use these? So one place you'll see folks use them a lot is somewhere like here. Think a procedure to press button. All right. You can do this. This is fair enough. It's not wrong. But my personal experience is to be sparing with these mental operators. I don't often use them unless there's an explicit need to do so. So how do we determine whether there's an explicit need to do so? Well, let's think about this case where we're doing think. That operator takes about a second. If you have an interface that you're familiar with, ask yourself, before you hit a button, let's say you're opening your phone app like we did earlier, do you sit and think for a second, how do I open the phone app? Well, maybe if you haven't used it in a long time or you're not familiar with the phone. But if you're familiar with the phone, you don't take a second to think about how to do it. It's what we call in cognitive psychology an overlearned procedure. That is, it's something that's become automatic. Kind of like the difference between, teaching someone how to shoot a basketball and you're telling them keep your knees bent and flex at your elbow and make sure you flex your wrist and that sort of thing. And as they shoot, they're trying to recite all those things in their head, as opposed to somebody who's been playing basketball for a couple years and isn't thinking about any of that because it's become automated. So if the procedure is automated, I tend not to use mentals, or rather cognitive operators like think or verify. Occasionally, I'll do something like this, cognitive processor verify finger is over the button. So what's going on here? Well, this is only 70 milliseconds. So it's a very small cost in terms of time. And it does represent something that happens mentally and probably happens at about that time scale, about 70 milliseconds, maybe double that sometimes. Verify finger is over the button. But it doesn't add a lot of time to the model. However, most of the time, you could just not do it at all. When would I use a cognitive operator? Well, a good example of that is when there is an explicit mental process. So let's go back into add contact to phone, and we're going to go down here to right here. One thing I might want to do here before I press done, also, I'll just write verify everything entered correctly. Okay. And there'd be a procedure for this. So here we've got a procedure for verifying everything's correct. So we read Alan in the text field, and that goes into working memory. And then we recall, say, how it's spelled from long-term memory so that we can make a comparison. And then I use a verify operator. So again, what's happening here is I would actually think in my conscious thought, okay, does Alan match? Yeah, that matches okay, I'm good to go. And I'd keep on trucking on down through here. Same thing, read Newell, recall Newell, verify Newell, etc. And here we have an explicit thought process that I want to model. Maybe this thought process takes 2 seconds, maybe it takes half a second, but using this kind of 1 second operator as a generic for a mental seems to work really well. Now, I'm going to come back to this in a second, but I want to mention one other thing. Let's go back to the scratch pad. Let's consider the look operator. Okay, it takes 550 milliseconds, I believe. Let me just double check that by going right up here, see, look, 550 milliseconds. Okay, great. But there's a lot packed into this look operator. And this is important when you're thinking about mental operators in GOMS. What is actually represented here, I could represent at a lower level of detail using Cogulator. So I could do attend to object on screen, initiate eye movement to object on screen, saccade to object on screen. And if you're not familiar, a saccade is an eye movement. So this is just saying move your eye and then look or fixate at the object on screen. And if I was doing it this way, I would change the time value to something like 150 milliseconds, maybe 300 milliseconds, just depending on what it is. Am I trying to perceive something binary or maybe a little bit more complex? I'd go up to 300 milliseconds and so on. If I'm reading, I'd go up from there. But here we have a detailed model of look. And there are occasions when you might want to use this detailed model. By and large, you're going to get away with just using look. That's normally what I would do. So what's the point here? Well, the point is, if we bring this up, you see there's several, if I get rid of this look here, there we go. There are 2 cognitive operators in essence built into the look operator. When I say built in, it's assumed in the total look operator time of 550 milliseconds. So we've got attend, initiate, saccade, which is that eye movement, and then look. We could just replace all this with this. So going back to our discussion about when to use mental operators, consider the fact that a lot of these operators already have mental stuff built into them, cognitive operators built in. And so you don't need to use them as much. And in general, this is what's called NGOMS, or natural GOMS language. And you can see some examples of that here, where we see look, point, click, versus here. And these examples are built into Cogulator, so you'll be able to go in and make a comparison. But these are basically models of exactly the same thing, just modeled using the more detailed method where we don't assume as much as going on in, say, a look operator, and the less detailed method where we say, hey, we're just going to use a look operator. That's good enough for the particular application we're working on. Okay, so long story short, when you're considering about whether to use a mental operator, my rule of thumb is whether or not the thought process is explicit. If it's an automated process, or a very, very short process, I tend not to include a cognitive operator, and if I do, I use the cognitive processor operator, which only lasts 70 milliseconds. So I'll do, verify cursor over the target. I'll do cognitive processor, verify cursor over the target. And then if you have an explicit thought process, like you're trying to compare two things, then go ahead and jump in and use the full the full mental verify or think operators to represent that. If we go back into add contact to phone, show an example where this might be useful. So right now we have all this information going in, and I'm going to do verify matches, meaning verify what I've read matches to what's in working memory. Well, guess what? All these items have decayed out of working memory. And so if I wanted to verify matching, I would probably have to ask one more time, hey, what was this again? Did I enter this correctly? And again, this is a great thing to model because it shows where pitfalls may exist. One other quick little aside I mentioned before I jump off of this, notice the numbers that have been forgotten in this case are in the middle. Why is this? Well, if you're familiar with working memory and the primacy and recency effect, what we know about working memory is that if you're given a set of numbers or words or whatever, you are most likely to remember after some amount of time the first digits and the last digits, and more likely to forget the stuff in the middle. That's called the primacy and recency effect, and I only point that out to let you know that Cogulator actually includes that sort of thing in its modeling of working memory. So that's a mental, or rather cognitive operators in a nutshell. Let's jump out and just talk a little bit about what we've learned today, because we've gone through a whole ton of material, and just see where we are.
All right, we covered a ton of stuff in this video today. Basic model building, goals, operators, methods. We looked at multitasking, goal references, chunk naming, working memory, really the whole 9 yards with Cogulator. It's a lot to take in all at once. So I wanted to remind you of a couple things. First, you don't need all that to build perfectly valid models in GOMS. If you want to start by just stringing some operators together, you don't have to use chunk naming, you don't have to use working memory, you don't have to use goal references or even goals. Just putting a couple operators together, again, perfectly valid way to build models in Cogulator. Second, you can look in the model sidebar, and there's examples there that are great for referencing how models are built and looking for some generic methods. The insertion Chi, that is when we press that purple button and we get the list of operators, there's also a list of methods there that are pre-built. You can use those to insert pre-built methods into Cogulator without going operator by operator. And finally, there's the magic models. So if you want to just demonstrate to Cogulator how to do something with the desktop PC or a iPhone, you can just demonstrate it using the magic models. So in general, my advice is start small and then work up to the more complex things like multitasking and cognitive workload in the form of working memory and chunk naming. Other than that, Cogulator.io is a great reference, as I've mentioned several times. Jump over to the primer. All this information is in there more or less, and it'll be a good reference for you. And that's it for this video today. Thanks.